Okay, so let's look at this. Let's think of, don't forget now, we can always substitute and stuff. All right, so let's look at the work real quick. Now, see, look, what I did is I went ahead and broke it apart here. So, gummit, I always forget to go to my pen. All right, so let's mark that out. So what do we wind up with? The average force, okay, if you want to write average, so be it. So we got what? 0.045 kilograms times the velocity, which is 25 meters per second. All right, y'all, what was the initial velocity? Zero, so just put a 0, right? I don't need to write all that down because 0.045 times 0 is 0. Okay, divided by 0.002 seconds. I should put it in scientific notation. But anyway. And so what did we get? 562 point... Good grief. Are you serious? Yeah, I am. Son of a gun. Yes. So 0.045 kilograms times 25 meters per second minus 0 divided by 0.0002 seconds. And the force is 562.5. All right, now, what are the units? Newtons. Right? Because this is kilograms, meters per second divided by a second is meters per second squared, which is a Newton. Okay? Now, notice the second part of the question. Is the effect of the ball's weight during the time of contact significant? Is the effect of the ball's weight significant? Okay, how much does the ball weigh? You can find weight, can't you? Remember how to calculate weight? So how much does the ball weigh? Mass times G? Not much, is it? What's that come out to be? Anybody got me an answer? 0.4? So is it significant? Compared to 562.5, we're talking about 400ths of a Newton? No. No. I was just asking. No. No. 400ths of a Newton compared to 562? No. Not enough to even fool with. Let's look at that. Number 16 is conservation of momentum, of course. P of A plus P of B is equal to 0, so that means PA minus PB, right? And the reason you have to have a negative in there is because notice on number 16 it says that an astronaut throws a tool. Now y'all don't forget, momentum, conservation of momentum is related to which of Newton's 3 laws? Very good, the third law. That's right. Because with it, remember, it does deal with forces. So when you throw that tool in outer space away from you, guess what the tool does back on you? Equal and opposite, right? So naturally your body's going to move which way? The opposite direction. So what should the value of your velocity be? If you're throwing in the positive direction, your body velocity would be what? Negative. No, not necessarily the same thing because masses are different. If the masses were the same, yes. If the masses were exactly the same, if you were the same mass as a tool, whoo, boy, then it'd be a big tool, wouldn't it? Would be for me anyway. A big one. All right, now. All right. Yeah, okay. All right. So your answer should be negative 0.105. And again, it's just momentum again. All right, let's see. Number 18 involves kinetic energy. I think it is it's also conservation of momentum, just what we just did, but it throws in kinetic energy. And 21 is similar to an elastic collision problem. Okay, similar, but it's not elastic. Okay, so which one do y'all want to do? 18 or 21?
18.
Okay. Okay, let's look at number 18 then. Let me minimize it here. We'll read it real quick. There it is. All right, on a frictionless horizontal air table, puck A with mass 0.25 is moving toward puck B with mass 0.35, which is initially at rest. Oh, I'm sorry, you said 18. I had my mind on 21. My bad. Start over. Two figure skaters, one weighing 625 newtons and the other 725 newtons, push off against each other on frictionless ice, which for the most part, ice is frictionless or very, 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 very low friction. If the heavier skater travels at 1.5 meters per second, how fast will the lighter one travel? How much kinetic energy is created during the skater's maneuver, and where does the energy come from? Okay. All right, well, first things first, we need to determine what? We need to determine the velocity of skater what? The lighter skater? Yeah, okay. So we need to determine the velocity of the lighter skater. Okay. So, what do we need to do? All right. Now this is what, number 18? All right, y'all. P total is equal to PA plus PB, which is equal to 0, right? So, we know then what? PA is equal to negative PB. Okay? And we'll let A be the skater that's heavier since it has a velocity, or he has a velocity, right? So what do? We plug everything in, don't we? So we've got the mass, let's see, what is that? Your final equation is going to look like this. V of B is equal to the negative of MVA over M of B. Right? And so we got 73.98, is that right? 73.98 kilograms. Now how'd you get 73.98? Notice it gave you the weight of the skaters, the weight of the skaters. How did I get 73.98? The weight of the skaters. I had to find it. Don't ever forget that, okay? The weight of the skaters. It didn't say weight, but y'all, if it tells you that a skater, where was it at? Yeah, 625 Newton skater weighing, well, it does say weighing, excuse me. It does say weighing. Weight of the skater. So I divide the weight by gravity. So 73.98 times 1.5 meters per second divided by, and that's negative. What's the mass of the other skater? 63.78. What'd you get? Negative what? 1.74? Yeah? Everybody see how I did that? A lot of these problems, 3 or 4 of these problems I've assigned are just repeats. We're kind of doing the same thing over and over and over. Okay? This was just like 16. Except now we're going to add one thing to it. Look at the second part. How much kinetic energy is created during the maneuver, and where does the energy come from? Okay? All right, now, listen very closely to what it said. It did not say what was the change in kinetic energy. It did not say that. It said how much kinetic energy. In other words, what was the total kinetic energy? Period. In other words, add them up. So you better listen to these, because it didn't say change in. Because if you think change in, you're going to put delta K and do a bunch of subtracting. No. There's one coming where we will have to do that, but not this one. So it said how much was the energy during this maneuver. All right, y'all, how do we find kinetic energy total? Well, it's either kinetic energy of A plus the kinetic energy of B, isn't it? Right? Because we can write kinetic energy total this way. The sum of all the kinetic energy. Same thing. Now, what happens to the negative velocity on that skater B? It goes away, doesn't it, when you square it? All right, so let's do that. K total is equal to 1/2. What is that? 73.98? Yeah. Kilograms times what? 1.5 meters per second squared. Plus, I'm going to drop down here, 1/2 times 63.78. Is that right? Kilograms. Times, we just found it, negative 1.74. Go ahead and write it in, but it's going to go away. When you square it, it goes away. And you get a K total of what? 180, right at it. 179.97, okay, 180 joules. Now it said what was the total kinetic energy during that exchange. Didn't say what was the change in. So gotta watch what it's asking for, or you will stump a toe big time. And I don't have any Band-Aids, sorry. You stumped my toe all the time when I was a kid. On the sidewalk, seemed like. Yeah, I was a klutz. But anyway. Okay? All right.
Were we supposed to do 23 and 33?
No, it was 21 and then 36. No, 36, not 33. 36 and then 47 and then 51.
So I don't know 23 or 33?
No, I didn't have them on there, did I? Did I have them on there?
Yeah, I wrote it down. So
Son of a gun, I did.
I just can't tell if I wrote 23 or 33.
Oh, yes, 33. Yeah, I overlooked 33. Yeah, 33, then 36. Yeah, I'm sorry. Yeah. 33, then 36. My bad. Okay, let me go ahead and give you the answer to 36. That way, if you work it. Okay. 36, you should get for part A 6.44 meters per second. 6.44, that's an inelastic collision problem. And part B, you should get 2.49 meters per second. Negative 2.49, excuse me. No, it's not. It's positive. I'm sorry. It's positive. Yeah, because 15 is negative. My bad. Okay? All All right, I'll tell you what let's do. We will come in Tuesday.